overwhelmingly surpassing Newton's universal gravitation. Physics genius Einstein astounds the world with gravitational waves. In 1687, physics' foremost figure Newton discovered universal gravitation, ascending to the realm of gods. However, Newton made a crucial mistake, believing that the propagation of gravity occurred instantaneously, just like how the Earth can instantly feel the gravitational pull of the Sun. Even if one day the Sun suddenly vanished, the gravity would also disappear instantaneously. It sounds very reasonable, to the extent that the whole world accepted this understanding, as long as it was Newton invincible in the world. But the problem is, if that were the case, many formulas of relativity would no longer hold true, since Einstein could bend space, slow down time, and eliminate anything contradictory to relativity. Of course, he wouldn't let universal gravitation go, based on the derivation of Lorentz invariance. In general relativity, Einstein predicted that gravity propagates at the speed of light. Let's take the Earth and the Sun as an example again. It takes about 8 minutes for light to travel from the Sun to the Earth. If one day the Sun suddenly vanished, the Earth wouldn't immediately know that the Sun had disappeared. It would only feel the disappearance of the Sun's gravity 8 minutes later. And this is the concept of the famous gravitational waves. You can imagine gravitational waves as water ripples suddenly appearing and spreading outward in a pool. Gravitational waves are extremely weak, but they still have a unique impact on the objects they encounter. To exaggerate a bit, when a basketball encounters a gravitational wave, it would be compressed into the shape of a football. After the gravitational wave passes by, it would return to its original shape of a basketball. Of course, this is an exaggeration. In reality, the distortion caused by gravitational waves is very small. So small that it is even smaller than the diameter of an atomic nucleus. With such tiny gravitational waves, it is indeed difficult to detect them. But after spending $300 million and waiting for 15 years, the United States finally succeeded in capturing the first ever gravitational wave signal in human history. That was on September 14, 2015, perfectly challenging the general theory of relativity. Einstein truly remains invincible.